Hello, this is exciting. This was going to be my first video, I think, because finally found what I wanted. So basically this is my reference elements of the differential and integral calculus by William Anthony Granville and Percy F. Smith, published in 1904. So basically, from my understanding, this book is in public domain, and therefore the copyright no longer applies, and so therefore I'm using that as my reference. Therefore I should not have any copyright issues with regard to any information I publish, and it's also it's also legitimate because of the fact that I'm using a legitimate source. However, I'm just a regular person, so I'm not anything special. Therefore, don't take anything I say as anything more than just something I say. Okay, so don't take it as fact. I am referencing a source, but don't say anything. Nothing I'm saying is necessarily a fact. Okay, I may be wrong about things. I'm just trying to. The goal of this is to just show you the way I think through things, and so you can to help other people. Okay, that's all. I'm not trying to say that everything I say is true, but I'm just trying to show you how I go about these types of questions with regards to calculus. So basically, I want to start with the sequence. Okay, basically, it's important to know the difference between a sequence and a series. A sequence is basically, a list of terms. Okay, so for this sequence, we have 1, then 1/2, 1/3, 1/4, and basically, they're separated. Each term is separated by a comma, and we can say that each term is basically un, and therefore for the nth term un, the term un is equal to 1 over n, okay, because we see that this is basically 1 over 1, 1 over 2, 1 over 3, 1 over 4. We see the pattern is that basically the denominator is increasing by 1 for each term, okay? So basically now, the series though, a series is a summation of each term in a sequence. So basically, think of it as this. This was the sequence. Now the series is going to be 1 plus 1/2 plus 1/3 plus 1/4, meaning that it goes on and on and on. So basically what people do is they represent a series specifically just to know this series is the harmonic series, okay, which is specifically an infinite series, okay, and it's denoted as this, okay, the summation from n equal 1 to infinity of 1 over n, okay. So basically what this is saying is you keep on adding up these terms from n equal 1 to infinity, so this keeps on going on and on and on. So, okay, let's explain this a little bit more. So basically, what are some things that we can figure out using some calculus? So by the divergence test, we know that the limit as n approaches infinity of 1 over n is equal to 0, right? Because as n increases to infinity, 1 over something really large is approximately 0, okay? So thus the sequence converges to the limit 0, okay? So basically what we're saying is, for the sequence, each term, as it gets bigger and bigger, the nth term, as it approaches infinity, is going to be approaching 0, and thus the sequence itself converges to 0. However, the harmonic sequence is unique in the fact that, let's explore this a little bit more, basically, even though the divergence test shows that the limit as n approaches infinity is equal to 0, sometimes that means, based on the divergence test, that the sequence also converges to, but there's an exception for the divergence test, which is that a series can still diverge even if the general term an approaches 0. So basically what we're saying is that even though we're adding up each term, even though the sequence itself approaches 0, right? Even though that's the case, the series itself, even though eventually we will be adding up 0 and 0 and 0 and 0, even though that's the case, it does not mean that the series itself converges. And the reason for this is because convergence and divergence has more to do with the rate of change rather than more so than anything else. So basically what I wrote is that this is because it depends on the rate of change. So basically, now the way that in this reference I gave, the way that they show, which is unique because I didn't see this before, okay, basically they showed you the harmonic sequence. Let me write that out. Okay, 1 over n, right? So, yeah, the sum of 1 over n to infinity n equal 1. So basically, this is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, dot, 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 right? So basically, what they showed, though, is they showed that basically, if you took this term, 1 is exactly that, 1. So if you took that and you got 1/2, that's half of this, so it's smaller, right? 1/2 is smaller than 1, and 1/4 is smaller than 1/3. So basically, what they did is they showed that by taking the second term and replacing what they showed is they replaced this first term with the next term, and therefore it's smaller, right? But when you add these up, you get a number, right, that's bigger than the previous term itself, thus showing that as n approaches infinity, the overall sequence is going to keep increasing. Basically, it's not going to level out, because you can see that if you add up these two terms right here, 1/2 plus 1/2 is 2 over 2, which is 1. But what that shows, even though that is equivalent to this right here is smaller than this, and it shows that it's larger than this next term, right? Or 1/4 plus 1/4 is 2/4, which is 1/2. But that in itself is larger than this next term. Okay, so the point is that basically, if you keep on doing this pattern, you see that you're going to be adding something. You're going to keep on adding a number, basically, and it's always going to be something larger than the next term. So basically, it diverges. Okay, let me go on and show you some other examples. Thank you.